Today we're going to go over the cofunction identity, which is one simple little trick to memorize or just keep in mind when dealing with trigonometry problems that'll let you solve trigonometry problems so much easier. You won't need to use a calculator. You won't need to get out and draw the unit circle or start thinking about triangles or trigonometric relationships. It will bypass so many difficult processes, and it's especially useful on the SAT or ACT or any other college tests or classroom quizzes or homeworks. But what is the cofunction identity? Well, simply put, it's that the sine of pi over 2 minus x is equal to the cosine of x, and the cosine of pi over 2 minus x is equal to the sine of x. And at first you might say, what is this pi over 2 doing here? Why is it there? That's because in this model, right, I'm dealing with radians, right? You know, where I go from 0 to 2 pi. If I wanted to write this in a more familiar degree form, I'd say sine of 90 minus x is equal to the cosine of x, and the cosine of 90 minus x is equal to the sine of x, right? So sine of x is equal to the cosine of 90 minus x, the cosine of x is equal to the sine of 90 minus x. Why is this really, really useful? Well, any sort of problem that you're dealing with, where you're plugging along, you're doing relationships, and let's say you find a sine relationship. You're like, oh yes, I found my sine relationship. But the answer asks or needs you to use a cosine. Well, what do? You turn to this identity, you take your sine value, you convert it into cosine value, and bing, bang, boom, you have a cosine that you can use, right? So let's say, oh, you know, and it can even help when you're dealing with difficult processes. Let's say you've done the math and you found the sine of 30, right? You also have to find the cosine of 60. Well, the cosine of 60 is equal to the sine of 90 minus 60, or the sine of 30. Oh, I guess I can use this as my value. And that's just one example where this formula comes in really handy. But what's more important is to understand why exactly this works. Why does this relationship exist? It seems kind of funny. It seems almost too good to be true. Why is this a thing, right? Well, let's think about it this way. Let's draw a right triangle. All right, a nice familiar right triangle. All right, here's my right triangle angle. Right, so I know that the sum of the angles in the triangle have to add up to 180 degrees. I already have this right angle here, right? So I know that the rest of these two angles here, have to add up to 90 degrees. I'll call this one x and this one 90 minus x, right? And of course, I'm going to label my sides A, B, and C. So let's say I want to find the sine of x. Sine of x is the opposite over adjacent, so the sine of x is A over C. And of course, this is 90 minus x because 90 minus x plus x sure indeed does consist of 90, which we know it has to be since we already have a 90-degree angle here. Right, so sine of x equals to A over C. The cosine of x is equal to B over C. The sine of 90 minus x is equal to B over C, and the cosine of 90 minus x is equal to A over C. As we can see, sine of x is equal to the cosine of 90 minus x, and the cosine of x is equal to the sine of 90 minus x. So we have this mismatching relationship, all based on the fundamental laws of any right triangle that we're dealing with, right? So for any right triangle, in fact, anytime we're dealing with any sort of trigonometric property, we're always going to have these fundamental laws and relationships that govern us and allow for the cofunction identity, which allows for this nice kind of reciprocal sort of thing, which makes it nice and easy to find trigonometric identities, solve trigonometric problems, and make your life a lot easier. So, I hope you found that interesting and helpful, and I hope you have a great